All right, welcome back everyone to day 3 of the Cyberbot Educator Workshop. That's the September 22nd, 2023 edition. Here is the link to the slideshow in your chat, in case that's going to help out. I updated the workshop agenda to reflect on slide 143 to reflect what we've done. Today, I'd like to just wrap up the whiskers, the whisker touch sensing with a little bit of troubleshooting. I think that'll be also kind of representative of some of the things your students will end up experiencing. So it'll hopefully be a good experience for all, regardless of whether you need help with troubleshooting or not. Then I'm going to talk about projects that are available, and as well as cybersecurity topics, our educational resources, and actually I got these swapped. The light, I'll overview light and infrared navigation, and then if time permits, we will work on a second circuit, which is navigate with infrared. As always, click view, and if you have a single screen, click the view in the upper right of what you can see for Zoom and select exit full screen, and then tile them side by side with your editor. Oh wow, I don't know how I managed to get an old editor back. I replaced those with the new editor. This is the old, we're in the version 3 editor, and this is the old version 2 editor. Okay, so on to touch navigation with whiskers. So this is a chapter in the Cyberbot tutorial series. So basically we have some prerequisites, which are learning how to use the online editor, learning how to write some simple scripts. And then there's also some additional ones down here that are not necessarily prerequisites. The last, these three right here, dictionary primer, exception handling, and strings and characters feed into the cybersecurity lesson. So they're not needed for the navigation and sensor stuff. It's only after that that those come into play when we start radio connecting the Cyberbot robots and hardening the network against cyber attacks. All right, so then we've done navigation. We skipped sound and circuits. They're pretty easy to do though, and we are here in touch navigation. So this is the first sensor circuit we'll have worked with. And then we've got visible light, infrared light navigation. Then we move on to radio communication. And then there's navigation with a keyboard. So you can, this is with an additional microbit, or if you have a classroom, one bot can be connected to the computer and the other can be out roaming, and they can be controlled through the keyboard, either first of all connected over a USB cable, and then secondly one microbit's connected, and then the second one is radio connected to the first. Then there's also tilt control, which is a lot of fun. That's also a second microbit or second cyberbot type of activity. Then we go into cybersecurity, and this is all optional. It just depends on, basically most teachers pick and choose depending on what they need to teach. And so if cybersecurity is on the agenda, we have some cybersecurity that involve both the microbits just as a part of a microbit network, and the Cyberbot robot as part of a microbit network. Then there are some projects down here. Now these, some of these are in support of a super kit that we have, and then it's a 12 pack for equipping your classroom, and there are some additional parts in that 12 pack. Some of them are also sold separately. So these projects in general require some extra hardware, unless of course for these three you have the 12 pack plus, and I'll be talking a little bit more about that later. There's also 3 more sold separately item projects that are kind of neat. I'll show you them all. Anyway, back here we are at touch navigation for the Cyberbot. And I think we left off with building the whisker circuits. So we went through and we built all this, and then moving on to the next. Well, I think I might have briefly talked about how the circuit works. I'll come back to that. And then for homework, we had testing the whiskers, and then after the testing worked out, then navigating by touch. And so I guess my question for you all is, how'd it go? Do we have any questions?
Hello?
Hello.
Yeah, my one of my pens doesn't on one side, on the left side, it inserts into the breadboard quite well.
Uh-huh.
And then the lower one, it just when it's just, you know how when you insert it into breadboard, it goes a little deep and it's just like it's kind of secures in a sense.
Uh-huh.
Like when you press it in there, mine doesn't even it taps on the top and it stays, but it's not like it doesn't press all the way through. It seems like.
Yeah, I actually had a little bit of trouble syncing one of my resistors in there too, and I kind of had to wiggle it to get it to go in.
Yeah. Do we have extra ones?
Yes, there are plenty of extra resistors if you want to swap it out.
Okay.
There's lots of red browns in the kit, and there should be extra brown, black, oranges as well.
Oh, now I got it in there. Oh, cool. Now it's in there.
Oh, excellent. Okay, well that's great. And so if that's the case, here I'm going to back up to the testing the whiskers. Let's make sure everybody got through this. Okay, so, and then this is the same drill where you'll want to have your microbit editor and you'll want to hit open and then go find Cyberbot template, which I'm probably going to rename to Cyberbot project pretty soon. It'll just be Cyberbot-project, and it will still be the same little Cyberbot light blinking that we see here. Okay, so once you've got your Cyberbot project or your Cyberbot template open, then we can paste over the in this case, the test script where we're testing out the whiskers, and then send that to the microbit, and then switching over to the camera.
The comments are great here.
Oh, do tell.
We have some saying the LED didn't work for me, but the touch whiskers did. Another, Mandy says the kids loved it, very interested.
Oh,
Mandy
wow.
said my dogs went wild, which made me laugh because all of the applications Andy does have been tested by various generations of cats in our house.
Yes.
Who sometimes discipline the robot.
Yeah, they show it who's boss.
Johnson said it went well. I enjoyed showing the whiskers projects to some of my students. And then we have some thumbs ups and all goods, and some who did the basic whiskers, but they didn't get to the roaming part yet.
Ah, okay. Well, that's something we'll want to make our way to. At any rate, the first test before we get there, I should paste this. I'll paste this in just a second. Okay, so the test script is back in the chat. And so now all we want to do is make sure that when the right whisker is pressed against the 3-pin header, the light on the right shows up. And then when you let go, we want the light on the right side of the robot. So here I'm pressing the right whisker and the right light is on. Then I let go and the right light goes off. Then pressing the left whisker, the left light is going to go on. And then when you let go, the left light will turn off. And then, of course, we want them both off when no whiskers are pressed. And you can actually also press both whiskers against both posts and you'll see both lights come on. And so if we all have that ready to go, then we're ready to start navigating using those sensors.
What do you do if the lights don't turn on?
Ah, good question. What do you do if the lights don't turn on? All right. So I think my checklist is going to be 1, is the script loaded? And so starting with that, we want to know, first of all, have you opened the Cyberbot template? So you can click project and just make sure Cyberbot Pi is there. And then you want to make sure that you have the whiskers _detect_test script, then hit send to microbit. So that part is making sure that you've got the right script in the microbit and that that you have the cyberbot.py module added to your project. Step 2 is going to be looking more closely at the robot. There are several things going on here. First thing is you'll want to make sure that all the batteries are inserted and in the battery pack. You'll want to make sure that your 3-position switch here is it can either be in 1 or 2 for this one. If you're going by the book, really, I think we want to have it in 1 since we're not really using the servos to move anywhere yet. And so your power switch needs to be in 1. Your microbit needs to be nice and firmly inserted into its socket. And then if you're still not, Stephanie, was it all the lights were off? The lights won't go on?
Says, what do you do if the lights don't turn on? And we also have from John, I can't get mine to work. I've done the circuit twice. So this is making me wonder about double checking the rows that the resistors are in, making sure they're in the same row as the 3-pin header. And then
Yes.
same the correct IO pin holes.
Well, yeah, so there are a few common errors. One is that there are some black sockets to the left of the breadboard. And one really common error is that instead of inserting it, well, see that causes when you don't have the circuit connected correctly, the light stays on. So I'm trying to think of what would cause the lights to stay off.
It could be that the whiskers are always touching the posts.
No, because if they were always touching the post, like if I had the whiskers stuck in between the first 2 posts like that.
Okay, so never touching the post, or maybe they're not, there's no, the connection to the 3.3 volts is not being made.
Let's see here. Okay. Yeah, that's a good point. So what Stephanie is saying with that, see if I can bring the camera a little closer here. That's a little bit saturated too.
There you go. That looks good.
Okay. So these brown, black, orange resistors. So, and it'll need to be brown, black, orange. So check your resistor values going from, so it needs to be, the brown, black, orange resistors need to be plugged into sockets labeled 3.3V. And these are going to be black sockets up top. So a black socket under the 3.3V label. That's where the upper resistor pins need to go. Then then one of those resistors needs to go in the same row with the 3-pin header. Now the 3-pin header also needs to be plugged all the way in. Essentially, you should be able to see
Yeah.
You should, the 3-pin part that is going into the breadboard, it needs to sync all the way up to the nylon, the nylon holder. I don't know. I don't remember
Oh.
what this nylon piece is called. So it needs to sync all the way in.
So we
Needs to
have
be in-
one of two working then.
Okay.
John got his working.
Oh, good job, John. The other thing is the whisker wire needs to come into contact with the metal part of these 3-pin posts that are sticking up here, not with the plastic part. If it touches the plastic, it won't turn on. It has to touch the metal part to make it turn on. Then essentially the next thing to do is to, let's see here. Since it has to be pulled up, since they're not coming on,
Oh, the other one is now fixed.
perfect.
I have it. I did it. Yay.
Hey, congratulations. We got,
Yep.
so looks like
Yeah,
we've got,
but I'm having trouble. I'm sorry.
oh no, go ahead.
Yeah, so I just looking at your diagram, I think I have one opposite way, but it doesn't matter what numbers they're going on the left side.
It
Well, on the
does.
left side, yeah, the left side is super important because essentially the script is set to monitor the P9 socket and the P7 socket.
Okay,
And-
P9, P7, I think I have those. Right, but I think I got one of the brown, vice versa. So yeah, I can see it better now. So brown goes, and they go on a 3 volt. I
So the
have-
red, brown, the brown, black, orange. Now it doesn't matter which direction they go. Like you can probably see that brown, black, orange is going from top to bottom on this resistor, and then gold, orange, black, brown it's the reverse direction. And for resistors, it doesn't matter. But yeah, so you need brown, black, orange up here going to 3.3 volts, and then you need red, brown going from the row of 5 that everything else is in to P7 and to P9. And these are the black sockets next to the breadboard, not in the breadboard, not in one of the white breadboard sockets, in the
Yeah,
black socket next to it.
so P7 and P9.
Yes.
And then yeah, but I never get the flashing lights. I get my lights are on, like my but there's no signal to the micro.
Okay, so the microbit is still not reporting that it senses a whisker contact when you push the whisker against the 3-pin header. It's just off.
both of the whiskers got just the 3-point headers.
Sorry, I didn't catch that.
Yeah. So just one of the whiskers needs to touch a 3-point header.
Yeah, when you-
Well, when one whisker touches one 3-pin header, one light should come on.
like
Yeah.
Andy is doing in the video at the moment.
Yeah. Oh no, that's not happening.
Okay.
Sorry, guys.
Is your microbit pushed all the way in? Can you only
Yeah.
see just a little tiny sliver of it?
Yeah.
Of
It's
those-
pushed out. Yeah, it's pushed all the way in. I looked at my
Okay.
batteries.
And your power plug is pushed all the way in?
Yeah, my power plug is pushed all the way in. Yeah, and I had the script correct. I found the
Hmm.
script, I sent it, it connected. Let me try it again. It says low system resources may affect your, oh no, that's the zone. So, yeah,
We know that one. And the light is on next to your power switch?
yeah, hold on. Yeah, so the light's on.
Okay, you have it in position 1.
Yes, it's in position 1.
Okay.
All right. Are you comfortable with unmuting? Well, you know what? Tell you what, let's
Keep,
do
no, keep going, and
yeah,
I'll yeah, keep going, and I'll
Okay.
just follow through.
I
all
have
right,
some
and we'll
more
try to
questions.
get you caught up on the break potentially too.
I have
What,
s- we have Carolee saying, I have my lights lighting up, but the right light comes when the left whisker is touched and vice versa with the right whisker. Could you demonstrate now that you're zoomed out a little bit to show that the whisker attached to the right post sticks out to the left and lights up the left
Okay,
light? Because the
so
whiskers cross each other, so it's a little confusing about which is the right whisker and which is the left.
it is a
whisker.
little confusing. Let's see, I need to back out a little bit, a little bit, just a tad more.
Yeah. There, that's good.
Okay.
And I think she's saying that makes sense. So, but just go ahead and visually demonstrate so we can
All
see how it
right,
can
so
get
we have
confusing.
the right whisker here. And
But it's attached to the left post.
it's attached to the left post
Yeah.
and it's touching the left 3-pin header, but the
Uh-huh.
right light is coming on because of the way the program, the way the script handles it.
But
So
the net effect is the robot is detecting an object on the right.
because of the script, yes.
Yes. Okay, good. We're getting it. That makes sense.
All
We have
right.
another question, which is, I lost my Cyberbot hex file under the main.py to run it. Does that happen when you restart the computer?
Yes, it does. That's why you need to open a Cyberbot template file at the beginning of a session where you're scripting the microbit. And so let me get you the page, or well, do you have so what I would do, I think, is I would hit I would copy the script. If you have it in there and you don't want to lose it, just shade it, right click it and copy it. Okay, and then after that, hit the open button in the lower right, and then find Cyberbot template.hex and open it and allow it to replace your file. And then you're going to have the one that just blinks the little amber lights on the Cyberbot board. And once you've got that open, you can simply right click and paste over that code that you didn't want to lose, so you copied it.
And I posted the link of the page to get that template file from, again, in case someone's on a different computer today.
Oh, that's a good point. Yeah, so Stephanie pasted the link, and so you can follow that link. And then you can right click Cyberbot template and select save link as. It's really important to right click and select save link as. And then once you hit save in this save as dialog, it'll show up in your downloads. And then after it does that, you can go back to your Microbit Python editor and open it with the open button. Okay, so hopefully that's got everybody situated. And once you've got that going, navigating by touch, once it's passed all the tests, navigating by touch is the next step. Now, I'm not sure why, but the author of this page chose some pretty small sleep times. And so the Cyberbot doesn't back up very far. I'll go ahead and copy this in so that we can all see that for ourselves. Okay, so I'm going to send this to Microbit. If you're in switch position 1, it's not going to do anything. You'll have to be in switch position 2 for this part of the activity. And what you'll notice is that the robot doesn't back up very far. And it doesn't turn very far either. So I'd like to improve that a little. And the way to do that is to take these sleep 250s right here and change them all. Let's try 850. I forget what I typed into the homework. It might have been 850 or 800. Okay, so I'll run this first and then paste it into y'all if it looks like it's a good balance for the robot. Okay, so again, I've got the switch in position 1, so it's not doing anything yet. Okay, position 2 hits the obstacle, backs up, and turns. Okay, I like that a lot better. So I'll paste in the modified version. Okay, so there is the adjusted version if you'd like to try that too. And keep in mind that, you know, maybe for the backwards, you want it to back up even further. And maybe for the turns, you don't want it to turn twice as far. So backwards, you might even change it to 1200. And then for the right and left turn, maybe drop it to 750. I don't know. I just, this is the kind of things that, you know, I encourage you and the students to experiment with, is because the distance is always your speed times time. So you can either increase the speed or increase the time. And I think the time is a lot easier to increase for this particular example. And then go ahead and give me a thumbs up when you have tried that out with the modified script. Ooh, I like the party popper. That's nice. Thank you, Heather.
Do we replace the whole
Andy,
script, the
Justin.
ones that we previously had, with that one?
Yeah,
Like copy that over the original one?
yeah, it can wipe out the whole previous script.
Okay.
Is it okay to merge the scripts so the lights stay on? I don't know how to do that. I can't think of how one would do that. Oh, I see what you mean. Okay, so so you're asking about integrating the lights into the other part. Yeah, that's going to be fun. Let's try that. So I need to go back to the testing the whiskers page. And I can, what you can do actually is just grab the if statement. The if, there are two if else statements right after the whiskers have been read. And so you can take these two statements and then paste them right below where the whiskers are read in the larger while true loop. Okay, and then you get the light and you get the action, hopefully. Let's try it. Excellent idea, by the way. Oh, interesting. My light didn't come on. I wonder what I did wrong.
It's that we're watching.
Yeah, and I'm trying to show off. Freestyling is always dangerous. Okay. So why didn't that work? I'm going to send a microbit and hit show serial in case there's some kind of script error, although there shouldn't be because I don't see any red dots on my, yeah, it says microbit flashed. Maybe it's just that I didn't press any whiskers. Hide
Is it
serial.
on 2?
Well, let's first make sure that the whisker pressing it's on 1 and answer to your question. Now, if I press, there we go. Okay. So it takes a little bit longer now for the light to go off because it's on 1. So the script is actually doing the evasive maneuvers, and that takes a little while. But when And the nice thing is the light stays on until it's done with the maneuver. I'll paste that in for anybody who would like to try it. You can paste it over your entire existing script. Control A, Control C. If you
Alex
have
is
them,
making suggestions either for baby student challenges. You could draw an arrow on the matrix also, or have it make a sound for the speaker when it hits something.
yes, those are really good suggestions. We should consider adding some of those. They might be in the navigating by touch. Let's see if
That's okay.
all
I mean to
right.
get you off track.
Okay. I'll stay on task here. Thanks. Okay. Yes, these are all really good challenges. I cannot paste the entire thing into the microbit editor. Let me see if I can just, let me see if just taking out that little bit, wait, will do the trick. I exceeded the number of characters. Okay, let's see if now it'll paste in. Nope. So this script currently has too many characters. What I'll do is I'll just paste in the part that you'll want to add right below the whisker left and whisker right read digital statements for those of you who want to try it out. Okay, so that's just the routine that needs to be added between whisker right, bot9 read digital, and then if whisker left compare equals 0 and whisker right compare equals. So that's where that routine is going to go in order to get the microbit to display at the same time you're navigating. Zoom has a character limitation on how much can go in the chat, and this particular script exceeds it. Okay. How are we doing on whisker navigation? Has everybody got a bot that's bumping into things and turning around, with possibly a few exceptions that we'll try to help out during the break or afterwards? Thumbs up. Very nice. Oh, thank you, Alex. Looking good. Thank you, Justin, Nelson. Oh, Donovan, nice job. Mandy, John, Jacqueline. All right. Yeah, we've got the thumbs up coming through. Sheila, good job. Heather, Sheila. Okay. So would you all like to try another application? We have the option to do infrared navigation. So what we've done is we've tried, oh yes, I see it, yes, right away. So what we've done now is we've tried the whisker contact, and so that one of the more popular applications is the infrared navigation. And I think we have enough time to get that done. So instead of doing the obligatory stuff, I'm still in the obligatory stuff. I'm going to skip over that, and we'll hit the whiskers. So very quickly, or pardon me, the infrared. So this is another chapter like the whiskers, and infrared remotes, some of them still are, but there's a lot of them that are switching to radio to control the TV. But previous to that, infrared used to have a little clear looking light bulb in the front of the TV remote, and you had to point it at the television as you pressed the channel or whatever button you were using. And inside the TV, there's an infrared receiver that would take this flashing infrared light that we can't see, but the remote was flashing it at 38,000 times a second. And depending on the duration, it would flash it for a while, then stop, then flash it again for another while. And depending on those times, those resolve to binary ones and zeros, which the TV would then put back together into a number like channel 6 or whatever. And so, oh man, you know what? I'm missing a slide. Sorry. Let's see if I can find the concept diagram inside the chapter. We also talk about infrared light and how it's below red in the wavelength category. Actually, I should say it's below red in the frequency. It's a longer wavelength, so it's a shorter frequency. Let's see if we can find the concept diagram. I don't know. Well, I apologize for this. There's a nice concept diagram that I had in some of the books that preceded this that showed the infrared light getting sent out and then either bouncing off an object and coming back to the infrared receiver or not, or going off into infinity. But I'm not seeing that here. So we'll leave that up to your imagination, and I'll go spelunking for the, oh, here we are. It's on the cover page. All right, so here it is. Sorry about that. Here's the infrared LED, the infrared light emitting diode, and it's flashing that invisible light at 38,000 times a second. And it goes out like a flashlight. And if it hits an object and comes back to the receiver, and again, this is the kind of receiver you would find in a TV set, the receiver will tell the microbit that it saw an object by sending the same signal, actually, that the whisker sends when you press it. And if it goes off into the abyss, the infrared receiver will send the same signal to the microbit as when the whisker is not pressed. And so now with that, we've talked about the TV remote. Now on, I'm going to text you, or I'm going to, yeah, I'll send this page through the chat. What it's going to have is it's going to have the parts list here for the parts you're going to want to grab. And we'll want to take apart our whisker circuit and then build this one up. And so here's the page. And this page is actually going to have the parts list, some instructions that you're looking for a clear light. You're looking for a clear plastic bulb with 2 leads coming out of it. But one of them has a rounded tall top and the other has kind of a flattened short top. And what we're looking for is the rounded tall top. That's going to be very important. You'll have to use this particular one right here. And what you're going to do is you're going to take it and you're going to put its legs. It's got 2 legs and there's 2 holes in the bottom of this black sleeve, which is one of the parts that you'll be searching for up here. And then you'll cap the lid on it so it looks like this. And the longer pin should come out of the hole next to the little plus sign on the bottom of the, it's called an LED standoff, and then this is called an LED shield.
We have a question. Can you leave the whiskers and do the IR also?
No. And so if you want to, I would suggest trying this out, even if you couldn't get your whiskers to go. And then if you can't get this to go either, we'll help you out with this and or the whiskers after the session is over. And then I can also Zoom with you just to make sure we've got it all squared away, possibly next week as well. So yeah, I'd say go ahead and take all the whisker stuff off. And then we'll go ahead and start building this circuit up. And these 4 slides, the parts, how to set up or how to choose your light. And remember, it's the taller, rounded, clear piece of plastic with 2 pins. How to put that in the LED standoff and shield. How to snap it in. And then how to build the circuit. Those are all on this same page. I'll text it to you again a second time. It's the same link as before. And I just follow that link. And so what I want you to do is get this list, and you may need to zoom in to identify the parts. So you may need to hit the little magnifying glass or control scroll wheel for your zoom so you can get a larger picture of the parts on your screen. And then again, all of those pictures I just talked about are right here. And then this will be another one where you want to really zoom in on it so that it's nice and large and easy to see. And so please grab those parts and build this circuit.
I have a request for the links again.
Okay. It's all on one page. There it is. Go ahead and narrate as I do this along with you. I am currently loosening the screw that holds the post so that the whisker can come out, and then I'm retightening the screw that holds the post. And you don't have to loosen it very far, just maybe a full twist. You can actually save the red, brown resistors because you need those for the other circuit. So you can pull out the, oh, remember to turn your power switch to off. So the PWR switch should go all the way to the right to 0. And then take out the 3-pin headers. Okay, so if I remember rightly, we needed 2 red and 2 black wires. There's 2 red. Here are 2 black wires. These are the 2 red browns that were in the breadboard already from the whisker circuit. And then the brown or the red, black, reds are going to be in one of these baggies. So I see 2 red, or I think 3 red, black, red resistors in there. So that's good.
So we know that resistor colors make a big difference, but we have a question. I have a pink instead of a red for a wire color. And for that, that's just the insulated coating on the wire, and the color doesn't make any difference. For the purposes of our tutorials, we generally use a red wire to show a connection to the voltage and the 3.3 or 5 volts, and a black wire to show the connection to the ground, and then blue or yellow to show the signal connections.
You
Just
should
for-
really teach these workshops, Stephanie.
Oh, no, no, no.
So this has been a 20-year debate. Let's see. So then we need our infrared stuff, which is all going to be in the plastic bag that has the tubes, and that's a really good thing. The receivers, actually, this whole bag here with the black plastic tubes is the remainder of what's needed after you've collected the wires and the resistors. There we go. And so then finding the little plus and minus marks, the longer pin should come out the hole with the plus mark, and the shorter pin should come out the hole with the minus mark. Mine is not cooperating. There we go. And then you can actually push it in all the way in, and then take the little shield, the smaller black tube, and snap it on top. Do that for both infrared light emitting diodes. That's these guys with the clear plastic case and the 2 pins of slightly differing lengths. Okay, when you insert these headlights into the breadboard, the anode plus lead is the longer lead. So wherever you see anode plus lead in the diagram, you'll want to connect the longer lead there.
Another question from Jacqueline. Do the red and clear bulbs take different voltage?
Yes, they do. the
when
red
you-
bulb takes 1.6 volts, I think. I'm going from memory here. Anybody can feel free to jump in and correct me if you're closer to electronics. And the infrared, I think, takes around 2 volts.
When you say takes, are you talking about voltage drop or the voltage that we connect them to on the board?
Well, the voltage that you're connecting them to on the board is going to be a 3.3 volt from the the red bulbs. Essentially, yeah, there's a when you apply voltage to them, they have to be in a circuit with a resistor, and they will typically show about 1.6 volts. And then the resistor will show the rest of the voltage that's applied across the circuit. And then when you have an infrared LED, I think it's 2 or 2.1 volts or something like that.
And in this circuit, we're powering the clear LED through the IO pin.
Yes, yeah, the IO pin is turning on and off, and when it does that, for on the IO pin, that from the black socket here, let's see here which socket. So P14, for example, is one of them that's going to be flashing the. Oh, I didn't connect that properly. There we go. So, oh boy, I used the wrong resistor. I'm not paying attention properly.
I keep interrupting you.
I hope my talking isn't doing that to everybody who's trying to build their poor circuits. All right. But you guys are all teachers. You've got nerves of steel, hardened in 180 days of classroom year. Okay. So yeah, the P14 socket is going to be set briefly to 3.3 volts, then briefly to 0 volts over and over again to apply and then stop applying voltage to this headlight right here. And you know what? I didn't pull out enough black wires.
We have the question, are we using the blue wires?
Yeah, so those blue wires, you can use any color wire you want there, but yeah, the blue, so I ended up doing the diagram using blue wires for the IR LED, the shorter pins, which are called the cathodes. And the reason for that is because there was an application that never got published where instead of running the pin to ground, it gets run to the D to A, and then the D to A makes the LED progressively more nearsighted by making it dimmer to get a distance measurement out of it. But I'll be showing you something very similar, but it doesn't require any tuning. Whereas the unpublished app that uses the D to A pins next to ground does require some tuning. Okay, so we need red wires to the topmost IR receiver pins, and they go to 5 volts, 5V in the upper right. And then the black wires go from the center pin of each IR receiver to a black GND socket. Oh, incidentally, make sure to keep your power turned off, and we'll want to check before we turn the power back on to make sure that the black bump on the face of it's like a hemispherical bump on the face of the IR receiver is pointing forward. So we'll go through that. Everybody keep your power off, and we're going to kind of do a checklist of items to make sure that have been that are checked before we turn the power on.
Another question, can you short circuit the breadboard?
Yes, if you insert a lead unusually far into the socket, it might be snaking around and connecting itself to other parts of the breadboard and inadvertently connecting 2 rows of 5 together. You can also accidentally run a jumper wire from, say, please don't do this, from say 3.3 volts to ground, and that would be a short circuit. Though it's not specifically short circuiting the breadboard, you can also inadvertently have 2 leads touching that are not supposed to be touching, and oftentimes that will lead to unexpected results on the whisker or infrared circuits. And remember, each circuit needs to sink into the socket you're plugging it into by about 1/4 of an inch to get a good electrical connection. And let's go ahead and take a break and then come back at about 6 past, or let's say 7 past the hour.
Okay, I'm going to pause the recording.
Okay, welcome back, everyone. Stephanie, you said you had a couple of questions that appeared in the chat.
Yep. Is it best to just use non-rechargeable batteries?
Oh, no, it's fine. Usually with the nickel, I recommend nickel metal hydride if you're using rechargeable batteries, NIMH. And I'll talk about that a little bit because they come with, we have some that we like at Parallax. And the main thing is to go with a high capacity rechargeable battery that can store enough to run the robot for a good long time. Some rechargeable batteries, some of the cheap ones or some that are older, they run out of charge too quickly and you might not make it through the class period. So if you use high quality, good nickel metal hydride NIMH rechargeables, that's going to be helpful, and I'll have more to say on that in a little bit. What's next?
And just an observation, Donovan got the interference sniffer beeping using TV remote.
Oh, cool. Thanks for checking that, Donovan. So what Donovan's referring to is that after building and testing the detectors, there's an activity called check for IR interference. And some of us may end up needing to do that today. I'm hoping not. But what it is you're running a script where it doesn't shine out any infrared light. It only checks to see if there's infrared light coming in. And it turns out that TV remotes, yeah, that's because you've got a TV receiver on the robot. And so if you shine a TV remote at it, you can, and you have the speaker attached, it'll make some sharp beeping noises and also flash the lights. The problem is that sometimes certain fluorescent lights will also send out a 38 kilohertz flicker. And because of that, we have students test and point at the lights in the main chapter. I'm hoping to get away without having to do that today. And then there's also something that we're going to skip, which is using different values of resistors, different resistors to, oh, I'm sorry. Let's see. Yeah. So here, first of all, we're learning about how a resistor can affect a light's brightness. And then what we do is we try that with the infrared light emitting diode to detect, to make it either more or less sensitive. And then there's a little YouTube video on that. Resistance versus distance. All right, so how are we doing? Have we all got this circuit ready to try out? Okay, so the first thing, let's see, can you change the IR to a different channel? I see each student controlling each. Okay, so so that's somebody who has an infrared TV remote and they're trying to drive the robot around. And yes, and the problem with that is that the students need to kind of stay away from each other. Otherwise, there will be crosstalk. And no, with most TV remotes, there is not a different channel. However, since you have microbits, you've got radio control options that abound. So don't worry, I'll show you that later, because the idea would be to have to use the tilt control application instead of the TV remote, and have a couple of students go off to a shielded area at a time with their TV remotes to try that out. Or possibly go out into the hallway. So the first thing I want to do is check and make sure that everybody has the little hemisphere bumps facing forward. So going to the video. These, see how there's a little hemispherical bump on the infrared receiver? That needs to be facing the same direction as the tubes are. It needs to be facing essentially forward on the robot. So the bump needs to be on this side, not over here. Absolutely not facing this direction. So each bump on the little square infrared receivers have to be facing forward. So check that. Another thing to check is to make sure that on the infrared receiver, the topmost pin is red and going to 5 volts. The middle pin gets a black wire and is going to GND. And then the lowest pin is what's connected to the red-red-brown resistor. Let me see if I can get a better picture of that on the diagram. So the best thing to do is to check, you want the anode lead, that's the longer pin, to be upward. Then you want to check because the uppermost pin of the receiver is for each infrared receiver, double check and make sure that the red wire is going from the uppermost pin of the receiver to 5 volts. So that's here and here. That's the uppermost pin of the receiver. Then the middle receiver pin should have black wires that are running to GND sockets. And then the short pin of each light emitting diode should have, it doesn't have to be blue. It can be blue or black. Has a bluish, or has a wire that's running to ground. So here's the short pin, little blue wire to ground. The short pin is the second row from the top. Again, blue wire to ground. Also check to make sure that the red, brown resistors are going to your receiver's bottom pin, the IR receiver's bottom pin. Then the red, black, red resistor goes to the infrared LED. And that's going to be reverse on the bottom from the way it is on the top, because the LED is above the top receiver, but below the bottom receiver. So, so on the bottom, you've got P1 to red, black, red to the long anode lead of the IR LED. And then you've got the red, brown going from P2 to the bottommost pin of the infrared receiver. Again, the hemisphere bumps need to be facing forward. And with that, we can load a script and turn on power. Okay, so I'm gonna, I'll find the script you need real quick. Let's see, test the detectors.
Can 2 wires be in the same box in the breadboard?
Well, possibly, but we usually want them each to be in their own socket. And then the trick is that rows are what connect leads together.
The 5 socket rows that go crosswise on the breadboard, not the on the long way.
That's correct. Let's see, I don't have a picture handy. Here we go. So here's a row of 5 sockets, and then here's another row of 5 sockets. And so here at the bottom, this bottom row of 5 sockets has the short cathode lead of the light emitting diode, and it's connecting to a wire that runs to ground. And then the next row up has an anode lead, and it's connecting to a red, black, red. That's a 2000 ohm resistor that then jumpers that also its other end is connected to P1. So you're always looking at the rows of 5 for your connections. Okay, so I'm going to paste in now. If any of you smell hot plastic, immediately turn power back to 0. And I guess I'll show you what I'm going to do first. I'm going to paste over the test script and send it to the microbit while we're still in 0. Okay, and then I'm going to set it to 1. And okay, so now that it's set to 1, if I am shining these lights off into the abyss, both of the amber lights in the lower right corner of the Cyberbot are on. Now, if I put my hand in front of, the right infrared LED and everything's correctly wired, the P21, the right of the two lights should turn off. Take my hand away, it turns back on. And then the same applies to the left light. The left LED, when I put my hand in front of it, the P20 light goes out. When I take my hand away, the P20 light comes back on. So that's what we want in position 1. And now I will paste you the script and have you try that too. Here you go. So load the script, set it to 1. We want, after about a second, you want to see the P20 and 21 lights come on with nothing in front of it.
Question, can you explain where the 1, 2, and the 14, 13 locators come from?
Where the 1, 2, and 13. Oh, okay. So the question is, why do we have the resistors plugged into these particular pins? And the answer is that has to correspond with the script, because the script is saying, okay, microbit, send the propeller microcontroller under the Cyberbot board, the IR detect command, and we want pin 14 to be what's connected to the infrared LED, and we want pin 13 to be what's connected to the IR receiver's output. And so essentially the script here has to match the electrical connections for the whole thing to work. And you can certainly, like, for example, if you changed this 13 to 12 and ran it, you would need to pop this resistor lead out of P13 and insert it to 12 before it correctly detected objects again.
The reply is, okay, so these numbers come from resistor locations and not the sensor location. What it's really doing is it's the number of the IO pin that is connected to the sensor, but it's connected through the resistor. So
that's correct.
So it's the resistor that's completing the connection between the row that the sensor is plugged into and the IO pin.
And in the case of the red, black, red, the resistor is actually limiting the amount of current that goes through the light emitting diode light.
You can show in the picture above the wiring diagram, the schematic, that just the resistor is just a wiggly line on the way between the IO pin and the sensor.
Yeah, so here's P14 and the 2 kilo ohm red, black, red. And we did skip the resistor color codes tutorial, so you're not expected to know that. But go back and look at that if you're using this to get ready for a class. So yeah, there's an IO pin, which is going to have rapidly turning on and off signals. And when it turns on, when it applies 3.3 volts here, ground is considered 0 volts. And so there's electrical pressure across the circuit, and current flows through the circuit, and the light comes on. And the resistor resists the flow of current. And so it's there really because it has to be in order to set the brightness of this LED light. The resistor that's going between the IR receiver's output and the IO pin that's listening to the output of the IR receiver is simply protecting the IO pin from short circuits. And it turns out that there's a large resistor inside this IR receiver, so it's not technically necessary. You could have used a wire in place of this 220 ohm resistor, but we try to, wherever possible, use a 220 ohm resistor just to make sure that that there's protection, because like whiskers and push buttons are things that could potentially damage an IO pin if there isn't a resistor in the way when certain mistakes are made. So we use resistors in place of jumper wires to connect to circuits that are connected to IO pins. Basically to make sure that certain mistakes won't damage the microcontroller that's underneath the breadboard here.
Okay, we have some more comments. We have, I'll tell both of them. P21 light is not coming on, and another, I keep getting an error showing no module named Cyberbot.
Okay, so the no module named Cyberbot, what you're going to want to do is first open the Cyberbot template file and then paste in the script over what's in the Cyberbot template file.
And if you need to get the Cyberbot template file, again, it can be downloaded from the page I'm going to paste in. It's the
It should be in your
orange-
downloads, but if you can't.
Kids, it's a new computer today.
Oh, okay. So when you go to the page that Stephanie directs you to in the chat, you'll want to right click Cyberbot template and select Save Link As. And then when you go through the save dialog, it should show up in your downloads folder. And then you can go to your Python editor, copy this script so that it's on your clipboard, hit open, find the Cyberbot template, that you downloaded, and open that, and then paste your script back over it and hit send to microbit. Okay, so we had then we had one where the P21, or did they say the P21 light stayed off or on?
P21 light is not coming on.
Okay, the P21 light is not coming on. So that means that the that there's something up with the circuit that is closer to the 2 amber lights. So it's this.
We have a reply to check the ground.
It's this area right here. And yeah, basically you have to check all the connections. Let's see. For example, if I float the resistor that goes from the long pin to the or I'm sorry, the resistor that goes from the bottommost pin to P2, the light stays off. No, if I float the P1 pin, it just stays on. So probably not the P1 pin. Check to make sure that your 220 ohm resistor is connecting P2, the black P2 socket, to the lowest pin, third up from the bottom of the, so the same row as the bottom pin of the IR receiver. Then check the center pin of the IR receiver, make sure that it has a jumper in the same row of 5 that's going to ground. And then lastly, check the IR receiver and the top pin and make sure it has a red wire going up to 5 volts. And then last but not least, you can pull out the infrared LED and make sure that the longer of the 2 pins is in the upper of the 2 rows it's plugged into, and the shorter of the 2 pins is in the lower of the 2 rows it's plugged into.
Yeah, I found the issue. It was the light and the sensor, I guess they were in the same hole.
Oh, I see. Yeah. So your sensor was
Yeah.
off by 1, probably.
Yes, that's what it
Mhm.
was. Yeah, as soon as I remove it, it came on. Yes.
Nice catch. And this is the kind of stuff that your students are going to have to do. This is troubleshooting. This is real world
Yes.
101 with the with the circuits.
Yep. Yep, it's just off by, they're in the same hole. So you got it. Thank you.
Thank you. Okay, so then we've got, hopefully, most of you are getting close to the point where you can put your hand in front of the left IR receiver and have the P20 light go out. And then put your hand in front of the right IR receiver and have the P21 light go out. And then, of course, come back on when you take your hand away. Once you've got that going, the next script that we'll have you try is, we're going to skip the whiskers style navigation in the interest of time. There's one where the script is just about the same as the whiskers, if I remember correctly. And we'll go to the high performance version here. This is the fast IR navigation script. What did I do wrong? Here we are. It's called fast IR roaming. And when we flash that into the microbit, I'm leaving mine in position 1, so it doesn't start moving quite yet. Okay, I think I'll unplug from the bot too. And then it will go forward and turn away from obstacles it detects. So like, here's my hand. And when it gets in range, it turns away, tries to find a new path. So even though it's coming at my hand, it won't run into it because it sees it and turns away. Black cove base that you see on the base of a lot of schoolroom walls, it absorbs infrared. So the Cyberbot infrared detection might not see that. Things like textbooks. So for example, I have a little hand drill case right here that is black. And so this is suspect because instead of reflecting infrared light, it might just absorb it. It might actually reflect it quite well. It really depends, but usually stuff like electrical tape and cove base, those kind of black things absorb the infrared light. So they're not good objects, but let's see, something else like a water bottle, which I don't see one off the top of my head. Looking for a decent obstacle. There we go. A small box is more reflective than my hand. It turns right away. Let's see if I move the box as far back as I can. There, it saw it. Here's one that's not published. For those of you who are waiting for something more. Oh boy, I hope this is not too long. Let's see. No, it's too long. I'm gonna have to paste this one in as halves. So this one, oh good, I'm getting some thumbs up. So do keep on working on the one that you've got. I don't know if I have the option of sending it as a file over the chat.
There, look at the bottom of the chat pane and there should be 3 little icons, a format, a little file, and an add emoji.
Oh,
I didn't know either. So
yeah.
good tip. Thank you.
Yeah, that is a nice tip. The problem is that I don't know if it'll let me send hex files, but I'll try it. Copy it first. Let's test it out, make sure I've got it right here.
We can also give them the page to copy it off of, or is it not there?
Oh, well, it's in the presenter's comments on the page it's in the presenter's comments of slide 206.
Okay.
That's one way to get to it.
And if I'll put the slide link back in for anyone who doesn't have it open.
I'm just going to paste this as 2 halves after testing it.
Okay, here's the first option. If anyone wants to go to slide 206 and grab that.
You'll need to drag the separator that's hiding the presenter comments way up. Okay, so what this one does is it follows the object that it sees in front of it. And I can even take it away with my hand here because the force is strong in me. And also, these are the droids you're looking for. And that back and forth motion is somewhat unavoidable. I haven't really, well, there are ways to clean it up, but it makes the code kind of lengthy and features some more advanced concepts. So we try to keep it as simple as possible, at least at the get-go. And again, this one is not published, but it is kind of a cool little app that uses the same circuit. And so now I need to paste that piecewise into the chat. So you'll need to be careful to, I'll paste all the beginning stuff first and then the while true loop second. So you need to paste the while true below the, okay, so there's the first part, whoopsie. Oh boy. And then the second part, they are separated by a couple of comments. Thank you for the comments, though. I'm glad y'all like this. Let's see here. Oh, good. Somebody was able to get it off the slides. Excellent. At least one of you. And then again, I pasted 2 halves of the script into the chat. So you'll need to paste the first one over everything, and it'll get you up to about line 20. And then below that, the second part will get you into the mid 40s, line number wise. And notice that it's trying to tell us there's a syntax error here. And I think I don't know why it's saying there's a syntax error. I'll have to take a closer look at that. Obviously the script works. If this was a real syntax error, the script would stop working. So, so ignore that. I like how raw microbits LEDs. Oh yeah. Thanks for mentioning that. Yes, let me, I'll show you that without the, okay. So, well, it's hard to see, unfortunately, but there is, it does give us a little bit of a sense of the distance away that the detector is seeing. And then they bounce around as it tries to find the right distance using both wheels and adjusting to both sensors. I like that you can push it back as well as lead it forward. And with that, we've got 20 minutes left, and I'd like to show you all a few things before we move to the question and answers part of, and if anybody is having trouble getting their bot to do all this stuff, please do consider hanging out after the session. We'll get you all squared away. Anybody we can't, we'll pick it back up next week. Let's see here. Bear with me while I find my spot. Getting closer. Okay. So the first thing I wanted to talk about was just, hey, we've got several sensor apps. So the first one is touch navigation, which you got to try already. And so here we are with the whiskers, and it bumped into the box. And of course, this came after building and testing the robot and getting navigation down. And then the next thing is a sensor application that does touch navigation. Following that in the textbook, we do light following. And there isn't quite enough time in 6 hours to get that one in. But here's a quick look at it. Basically, the robot coming forward, and when the flashlight hits it, it starts following the flashlight beam if it's right in front of it. So again, here it comes forward, flashlight beam, and it starts following it. During that, students get to learn lots of neat things about visible light. Then we have the infrared one, which we just did. And it essentially is a non-touch version of the whiskers, where when it sees an object, it turns away and finds a new direction. And that was the whiskers version, as opposed to the slightly higher performance one I had you guys try. Now, there are some really neat apps for classrooms where there's lots of microbits. Also, if you're on your own, you can just buy a second microbit module or borrow one from your classroom to try these out yourself. And so this is probably one of the most popular ones right here. It's keyboard control. And there's one microbit connected to the laptop that's broadcasting on its microbit radio to all the other microbits on these cyberbots that are receiving it on their radios. Okay, here we go. So here is the microbit, and then we've got the serial monitor open. And Ken is going to be typing in information on how fast each wheel should go and the amount of time that the maneuver should last.
One of you was mentioning square dancing robots. If you faced 4 robots inward toward a square, this technique would also be able to make them square dance in unison.
That's a really good point. And so what this script is doing is it's prompting you to enter the left speed, the right speed, and then the milliseconds to run. And then it creates something called a dictionary, which is one of the more advanced scripting lessons in the prereqs. And it sends that across the airwaves to the group of cyberbots. And the effect is pretty amazing when you've got the whole classroom of bots. Okay. So could everybody see that okay? Was that visible, Stephanie?
Yeah.
Okay, good.
We have marching bots and the swarm.
Yes, exactly. And this is intentionally done unencrypted to give us lots of tie-ins for cybersecurity, which I'll swing back around to in a little bit. Here's another one. This is tilt control. Both microbits are actually showing the direction that the controlling microbit is tilting it. And so when you tilt left and right, it tries to turn in place. And when you tilt away from you, it drives forward. When you tilt it toward you, it drives backward. And then, of course, left and right will cause it to turn left and right. And the amount you tilt controls the speed it goes.
I recall we had a question about being able to have multiple robots in a classroom and using different channels.
Indeed, we did. And this is the way to go. It's especially popular for robot sumo wrestling to have the tilt controllers. Just be ready to have the students spend the rest of the class period on it once you get them started. Okay, then so those are 2 applications where a second microbit is required. And again, in a classroom, that's not usually an issue. Another thing about these radio applications is that there's a lesson where students, part of the instructions are that students each pick their own, pairs of students each pick their own channel. And the channel goes from 0 to 83. There are 84 different radio frequencies that you can use for this. And so we usually separate them as far as we can. Like, if you have, say, 20 pairs of students, or let's go with 10 pairs of students, then that's going to be 10 channels. And you could actually keep them 8 apart. So the first channel could be 0, the second channel could be 8, third channel could be 16, and so on, all the way up through 80. Cybersecurity, that unencrypted radio connection is really great. And you may have noticed in the Cyberbot tutorial series that we have some after infrared light navigation. That's the one we just finished. Cybersecurity radio basics. That's where you learn about the radio. Then radio data. So these are 2 microbit activities as well. Then that leads into keyboard control and tilt control. And then after that, there's lots of robotics contests that can be done, and students learn about how to encrypt their messages, how sniffing attacks work and how they can defend against them with encryption. Likewise with brute force attacks and defenses. Malformed packets is another way to cause a robot to stop in its tracks during a contest, for example. And so these are using that unencrypted radio for the most part, and adding encryption by actually scripting the encryption right into the application. Pretty neat stuff. And there is a subset where we focus on the microbit only lessons. Essentially, that's the cybersecurity series. And so we have pretty much some similar prerequisites. And then just the radio and encryption stuff. And then, of course, they end up skipping, like in malformed packets, for example, we skip the last one, which is where the Cyberbot robot scripts are. So this is keyboard control, and it's a malformed packet attack using the keyboard control app I showed you, whereas this malformed packet attack is just working on sending messages between one microbit and another over the radio. And when you send a message with a malformed packet, then that causes the microbit that receives it to stop in its tracks until you go back and use some of the earlier lessons about, about exception handlers and adding those so that malformed packets cannot stop your microbit or your robot in its tracks. If time permits, I'll demo that one, or it's going to be a close call. So the cybersecurity, we have not posted Spring's cybersecurity session yet, but that's coming soon. And there's a previous one that I have posted on this slide. And this is the case with all of the courses we do. This page right here has the 3 workshop videos at the top and then the slides at the bottom for a recent cybersecurity workshop. So if you want to do it at your own pace, there's that. And then if you keep an eye on our email announcements, you'll know when the next cybersecurity class is scheduled for spring as soon as we post it. So again, this is the malformed packets that I'll come back to if time permits. There's a line follower, and the line follower is now we're talking, I'm sorry, now we're talking about projects. So again, if we go to, I'll just go to a project and then navigate upwards. So in the Cyberbot, we've got the prerequisites. This is mostly about coding in the editor. Then we've got the main lessons that involve the Cyberbot, and then some microbit only stuff is salted through here too. And then we've got projects along the bottom, and these are the ones that involve sold separately items, or in the case of these 3, these come with the also come with the class pack, the 12 pack of Cyberbot robots. And so that's these 3 projects. And what I did is on each slide, I put links. So like if you're interested in the 12 pack that has the line following hardware and the TV remote and a rotating ultrasonic sensor that that you can mount on the front of your robot, that each one of these is included in the Cyberbot 12 pack plus for classrooms. So you'll see that link on each of these slides. Now, additionally, there is a bundle that has just the QTI line follower, but for the rest of these guys, it's either in the 12 pack or it's sold separately. So like if you get a number of Cyberbots and then decide, oh, gee, you know, I'd really like to add the line follower to my Cyberbots, but I already bought them just individually. Well, here's an individual QTI line follower kit that you can purchase that bag of parts and add it to your classroom inventory. We also have some projects that are just for sold separately items. This one is really cool. Let's see here. So this one's kind of fun. Here's the tilt control that I demoed earlier. And this microbit has it loaded in, and it's modified so that the buttons will open and close a gripper that can be mounted on the Cyberbot. And so that's the A button to close the gripper. And then I'm using tilt control to back it up and turn it, and then find a place to set it. And then the B button opens the gripper, and then we're parking the robot. So that's a neat one. It's the gripper module. We've also got some of you asked about the servo motors, because we had to adjust the code a little bit to get the robot to go straight ahead. Well, it turns out that there's a kind of servo that you can use where it has built-in what are called magnetic encoders. And what they do is they tell the microcontroller underneath the Cyberbot board's breadboard what position the servo has turned to. And so keep an eye on this little white mark right here. As it goes forward, it's designed to go forward so that it makes only one full turn of the wheel when it goes forward and backward. So you see how that it's always pointing down, and this is showing that it has the ability to know its wheel position. And the scripts are a little bit different, but there's a tutorial about how to adjust the script to make it talk to the Feedback 360 servos instead of to the standard servos or the continuous rotation servos that you have in your kit. So that's another option for an upgrade. And the last upgrade is the gripper kit plus the high-speed 360, the Parallax Feedback 360 high-speed servos, pardon me. And let's see here. So here's an example from that set of lessons. Yeah, that wasn't the one I intended to show you. Basically, this is the same thing, just using the high-speed servos with the encoders. There's another one. Okay, so there's the gripper control. How about go and get an object? This is the one I wanted to show you. Okay, so this is a challenge for the students where they are given distances and then they have to put into the script what's needed based on how it works in order to do something like go forward a certain distance, grab a block, and place it on a Post-it note. We also have a series that uses a different board for electronics lessons. These are pretty neat and may be applicable to some of you. So I'll show you just very quickly some of the things that you might end up seeing. It goes a little bit more deeply into electricity and electronics than the Cyberbot tutorials do. And this is an example where we're using the microbit to measure voltages, and those voltages are being displayed on a virtualized web page version of a device called a voltmeter. And so when we take these alligator clip probes and put it across the circuit, we see 3.26 volts. And then across the resistor, we see 1.2 volts. And then across the green LED, we see 2.06 volts. And then that feeds into a lesson where basically the sum of the voltage across the two parts should equal the whole of the voltage applied across it, which is Kirchhoff's voltage law. And so that's just an example of many different kind of electrical measurements that are done using this virtual thing called the, can we do that circuit on the Cyberbot PCB? You know, you actually can. for many of the circuits, you actually can do the circuit and the measurements, because it's a really good question. Well, if you look closely at your Cyberbot, in the lower right of the breadboard, you'll see AD0, 1, and 2, I believe. Yeah, A/D 0, 1, and 2. And 0 is used to measure the voltage with the black probe, and 2 is used to measure the voltage with the red probe. So you could actually build that on your Cyberbot board. One other fun thing about this is that it has a built-in oscilloscope too, so you can actually do things like measure the signals that are being sent to the servo to see what they actually look like and measure their timing, because it's the time that well, basically there's a rapid set of on-off signals that you can measure with a device called an oscilloscope. And the same web software has that oscilloscope. Let's see if I can just quickly show you that. Cyberscope.parallax.com. Okay, so here is the Cyberscope. And I'm going to download just a demo hex file, which is a little bit different from the ones that we have. And then I'll open that and load it into a microbit. Try Cyberscope. Send to microbit. Okay, and then we'll go back to this one, to the Cyberscope, and hit connect. Embed serial port. This is from the instructions. And so this is the oscilloscope part, and it's showing two different waveforms that are very common in electricity and electronics that have to be measured for a whole variety of technician and engineering level activities. And then in addition, after this, it also will show some of the multimeter measurements that are supported. And again, this is the microbit just sending data points to the oscilloscope, and it does it either as it can actually measure voltage, current, and resistance. You have to follow through the tutorials in order to get it to do it. And it has amazing things. For those of you who have worked with an oscilloscope, you can, for example, zoom in on the waveform, and you can even adjust the oscilloscope to tell it when to trigger the waveform. So this is kind of some advanced electronic lessons that can be done with the microbit. And yes, you can take the measurements on the Cyberbot. It just takes a little bit of, or it takes a certain amount of additional knowledge, that because there's nothing published on that at the moment. But if you want to reach out to me directly, I can give you a few tips that should get you down the road if that's something you'd like to do. Here are some of the main workshop links we've taken a look at. One I forgot to mention to you earlier on was that very down in the way bottom left, there's a question mark on the editor. Here's the question mark, and when you click it, one of the things is MicroPython documentation. And this is a page where it's got links to all the different microbit features for Python. Like if you wanted to learn more about the radio, they have a radio example. And then also they have information about the API, that's the application programmer's interface. And so you can learn more details about the radio through this API reference for those of you who are into more advanced stuff. And let's see here. Uh-oh, it's 3 minutes past the hour. I'm running you guys overtime. Student lessons are at learn.parallax.com, and teacher resources are also there. So if we go to learn.parallax.com, the links are in the slides. The educator resources are here. There's tabs across the top, and you can log in as an educator. And when you're a student and you come here, like if you wanted to look at the Cyberbot resources, you would see all the public stuff. Like there's the slides that we have. There's a standards matrix. But in order to get to the assessment materials, it's telling you to log in. And so I'm going to log in off screen. They do actually now say that that there's an AI that can tell what your password is. So I guess technically I should mute my audio, but I think I'll instead opt to change my password later. So I'm gonna okay, so here I am. I just logged in and on my teacher account. And so if I go back now to learn.parallax.com and click on educators, now when I go into Cyberbot resources, we have the educator downloads, and this has assessment material. So for example, if we were looking at navigation assessments, there's a zip you can download. And then looking at the zip, there we go. Okay, so when we unzip this, extract all, we'll get a folder full of assessment documents. And essentially there are two versions of the same doc. There's the Word version and the PDF version. So I'll just open the PDF real quick in my browser. And keep in mind that part of this is a handout that you can send, that you can give to your students, but make sure to only print where it's all black, because when you get to red, that's where the solutions are. And last but not least, we've got some workshops coming up. I'll go ahead and paste this in again. Really sorry I'm having you guys stay after. This is a reminder that Make It Code It has some good projects. This was that when I click the question mark in the editor, this is the web address of it. Remember that cyber.org has some teacher-led resources for you. And then there are links to, like on slide 190 and 191, we've got links to the Cyberbot on its own, and then that 12-pack that has the extra line follower and ultrasonic. There's also a link if some of you have Bobot or ShieldBot robots. Those are earlier incarnations before the Cyberbot came along. You can purchase using this link a conversion kit, which is essentially just the board on top and a 5-cell battery pack to upgrade from the Bobot to this. And you don't actually need the 5-cell pack if you're upgrading from the Arduino to this, but it's in the kit anyway. Here are 2 kits that are nice to have on hand. You've got some extra parts. I should go back to this kit because it shows the rechargeable batteries. Somebody asked about rechargeable batteries, and Parallax does carry rechargeable batteries. Stephanie, if you could paste in a link to those, that would also be really nice. And then the second to last slide is the our contact information. Education@parallax.com is usually the best one to use if you have any kind of question, be it purchasing assistance. I need help because, you know, my robots aren't doing what I expect, anything like that. Of course, sales, if you have a PO ready, go to sales@parallax.com. They can also help you with some basic questions, but if you're at all concerned about getting the right thing to get the lessons you want to your students, hit us up at education@parallax.com and the right person will get back to you. And then remember to unplug power, everybody. Very important. Unplug that power before you go. Thank you from us. Cyber.org sends out their thanks, and we are Parallax. I'm going to switch over. Remember again, unplug your Cyberbot's power supply before you finish your day. Have a great weekend, everyone. And if you want to stay around after the recording stops, we can help you get your circuit fixed if you have any kind of issue getting the infrared going. Thanks again for coming, everyone.
Thank you.
Thank you. We're still recording.